Okay, now that we know about the square root property, we can use that to go through and solve some more problems. So here we have one that says y squared equals 100. So this is, basically we're just solving for the variable here. And if you think about it, then we're doing the same thing that we've always been doing, solving for the variable. We're going to have to undo this square to get the variable alone. So the opposite of squaring would be to take the square root. We can do that as long as we do it to both sides. So the square root of y squared would be y equals the square root of 10 would be a positive, the square root of 100 would be a positive or a negative 10. So our solutions here would be negative 10 and 10. Either one of those you could square and get 100. Okay, what about something like this? Here we have m squared equals negative 25. Now before, when we were working these problems, we said we can't do that because you can't square something and get a negative number. But now we've been introduced to imaginaries and complex numbers, and so we know now that we can do it, not in the real number system, but in the complex number system. I can do the opposite of the square of m squared, which would be m, square root of m squared would be m, equals the square root of, if this was just a 25, then it would be 5. But because we have the negative, we have to add in the imaginary there. So this would be a positive or a negative 5i. So our solutions would be negative 5i or positive 5i. Okay, let's do a couple more here. Here we have one that says d minus 1 quantity squared equals negative 18. And again, you cannot square something and get a negative number in the real number system, but we can in the complex number system. So I would need to, first of all, undo this square by taking the square root of both sides. So when I undo that square, now we have d minus 1 on the left equals, and on the right we have the square root of negative 18. Well, 18 is not a perfect square, but I could break it up into 9 times 2, and we could take the square root of each one of those. So this is going to give us 3 square roots of 2, and because of the negative, we have to add in the I. So it's positive or negative, 3 square roots of 2, and then the I for the negative. Now we're still not done. We haven't solved for d here. So we need to add 1 to both sides. Now when we do that, I'm going to add it and put it in the front of this so that we don't get confused. So this is 1, a positive 1, plus or minus 3 square roots of 2i. Our solution set, if we break these into two separate items, would be 1 minus 3 square roots of 2i, and then 1 plus 3 square roots of 2i. Now for this final one here, we can't undo the square until it's all by itself, so we need to do some moving around first. If we take this 2 to the other side by subtracting 2, we now have 5 times x minus 3 squared equals 25. And then if we divide both sides by 5, we have x minus 3 squared equals 5. So that's what you will always want to get. In order to use the square root property, you have to have the perfect square by itself, so that then we can take the square root and undo it. So that would be x minus 3 equals plus or minus the square root of 5. And then we have to add 3 to both sides to get x equals 3 plus or minus the square root of 5. And our solution set would look like 3 minus the square root of 5 and 3 plus the square root of 5.